Okay, welcome everyone. It is time for our first session to start. Let us welcome Professor Suresh Sharma sir. Let me give a brief introduction about him, and I hope that I'm audible to everyone. At present, he is currently the professor at Department of Statistics, Punjab University in Chandigarh, and he has remained the chairman of that department previously. He has also been a coordinator for Center for Systems Biology and Bioinformatics. And his research interests are biostatistics, statistical modeling, distribution theory, statistical genetics, and bioinformatics. He has more than 26 years of experience, and a lot of projects have been taken by him, and from not only from India but from outside India also, such as from USA, UK, and from Boston, USA, and Commonwealth Secretariat in United Kingdom. And others are also there from India as well. He has more than 122 research papers in national and international journals. And the most important thing is that he has visited more than 37 international conferences abroad, and he has given more than 850 invited talks in India. He has conducted many workshops on SPSS, Minitab, R, and other software. Uh, he has been the recipient of many awards and honors. Some of the major ones are from USA, Jacob Wolfowitz Award, and other than that, he has been the Best Citizen of India Award also. And he's a advisory board member at London School of Management Education in London. And he has also visited countries from Sweden and Russia as well. And at least the countries visited, some of them I'll state are USA, UK, Austria, Singapore, Malaysia, Indonesia, France, Turkey, and there are many more to list here. And he has guided many PhD students, and he has worked on developed his own website regarding some cancer projects as well. So I'll hand over to Sir now. Sir, welcome.
Thank you, Dr. Faz. It's really a privilege for me to be a part of this program. And first of all, I would like to thank the Vice Chancellor of the Aligarh Muslim University and some of the senior faculty members of Statistics Department, Professor Qazi Mazhar Ali, Professor Akil Ahmad, Professor Attar Ali Khan, and I am a regular visitor to Aligarh Muslim University. I visited a number of times, and whenever I am there, it is just like homecoming for me. But this time, as you know, because of the pandemic situation, this is online program, so we could not meet physically. But anyhow, whatever the mode is, it's always going to be interactive. It's always going to be informative. So once again, I welcome all the participants to this first session. And as you know, this entire workshop and the program is on data analysis, statistical techniques using data analysis, and different softwares you will be introduced. I'll be introducing SPSS. Some others will also introduce R and some other softwares. So it will be a very good experience for you, and hopefully you will enjoy the sessions throughout the 5 days of this program. And I would also like to thank the AICT for providing the funds for conducting this program. So without any delay, let me start with very basics, because as I came to know that most of you are not from statistics, some of you are from engineer background, some of you are from management background, and some other backgrounds also. So I will start from the very basics so that everybody can understand. And in between, you can ask me questions also. Once one topic will be over, I'll give you maybe 4 or 5 minutes to answer questions, or you can put your question into the chat box so I can answer that. So with this background, I will start. Let me share the screen and start with the proceedings. I think about 77 participants have joined. Dr. Faz?
Okay. Yes, sir.
So let me share the screen
About
and
77.
then start with. Can you see my desktop
Yes, sir.
now? Is
Yes,
it
I hope
visible?
everyone else can see it also.
I think so. It should be visible.
Mhm.
Okay. So this is a faculty development program on statistics and optimization technique using statistical softwares. Now, first half an hour will be important in the sense because unless or otherwise you are not familiar with the nature of the data, types of data, it is difficult to carry out any type of statistical analysis. So first half an hour will be important. I request each and every participant to concentrate on few slides, which I'll display in the beginning because they will help you to understand the rest of the sessions. Okay, so first I'll touch upon the part which is called research methodology, then I'll come to SPSS. Now, if you look at the nature and types of data, now any type of data, basically either it is called a structured data or it is called unstructured data. Now, what do you mean by structured data? Structured data is the one where features can be easily extracted. For example, if I give you 50 observations and I ask you to compute mean, median, mode, skewness, kurtosis, percentile, deciles, you can easily compute for 50 observations or maybe 100 observations. So features can be easily extracted. And most of the time, the structured data is in the numeric form. But what happens sometimes the data is not exactly in the numeric form. It could be just like a label. For example, gender. The gender is not numeric as such, it's male and female. But I can always assign certain codes, say male as 1, female as 2. So it becomes numeric. Similarly, socioeconomic class. Say lower class, middle class, upper class, I can write 1, 2, 3. Right? So all this type of data, which is also convertible into numeric form by assigning certain codes, is also comes under structured data. So what is basically structured data? Either it is already in the numeric form or it's easily convertible into numeric form. This is what we mean by structured data, where features can be easily extracted, whether it is easily convertible or it is numeric. If it is easily convertible, you can count how many males are there, how many females are there, how many people belong to the lower class, middle class. So all these things can be easily extracted. Then there is unstructured data. What do you mean by unstructured data? Unstructured data is the one where features are not easy to extract. It's very difficult. For example, everybody is using WhatsApp. You are receiving hundreds of messages, videos, pictures every day. Information is there. But if at the end of the day, I ask you to convert this entire information into numeric form, I don't think it's easy for anyone. But information is there. They are obviously talking about something. So this kind of data, which is not in the numeric form, comes under, which is in the textual form, basically comes under what is called unstructured data. It's easier to deal with structured data, very difficult to deal with unstructured data. And two of my students from bioinformatics and two from statistics, they have completed their PhDs only on unstructured data. Without reading the text, we can tell you what they are talking about. Without reading the text. And people also talk about these days big data. Big data is basically a combination of structured and unstructured data. There may be some part which is structured, there may be some part which is unstructured, and a combination of these two sometimes forms what is called the big data. People also talk about the semi-structured data. That also covers a part of big data. Now, as far as this program is concerned, we'll not focus on unstructured data. Basically, our main focus will be on structured data and structured data which is in the numeric form. And if you look at the structured data, it is basically of two types. Either it is called categorical data or it's called measurement data. Now, what do you mean by categorical data? Categorical data is the one where the measurements are in terms of categories. For example, gender. Say I can write male as 1, female as 2, or you can write female as 1, male as 2. So it's just a category. Similarly, socioeconomic class, lower class, middle class, upper class, I can write 1, 2, 3. Religion, I can write Muslim as 1, Hindu as 2, Sikh as 3, or you can write in some other order. Doesn't matter. So this kind of data where you have properly categories, they comes under what is called categorical data. And what is measurement data? Measurement data means some kind of instrument is being involved in measuring something. For example, you can measure height, you can measure weight, blood pressure, cholesterol, skin fold thickness, chest measurement. So all this kind of data comes under what is called measurement data. But sometimes we don't require an instrument, but it could be a measurable quantity. For example, to measure age, you don't require an instrument, but age can be measured in years. You can add even months, days, minutes, and seconds. So it becomes a measurable quantity. So this is what we mean by categorical data and the measurement data. These are the examples of categorical data. Hair color could be brown, it could be red, It could be black. I didn't put a white there because people sometimes get depressed. Our entire body is made up of 4 types of nucleotides. They are known as ATGC. And the entire COVID research or any type of genetic research is revolving around these nucleotides. So I can write A as 1, T as 2, G as 3, and C as 4. So you can categorize. Eye color can be coded as 1, 2, 3, 4. Gender can be coded as 1 and 2. Disease mild, moderate, severe as 1, 2, 3. And genotypes, depending upon which one is dominant, which one is recessive, you can write 0, 1, and 2. So all this kind of data comes under what is called the categorical data, where you can simply, the different labels can be categorized like 1, 2, 3 or 1, 2, depending upon how many categories are there. These are examples of measurement data I have already explained, like cholesterol level, height, age. This FPKM value is basically called, whenever we conduct this Illumina experiment, entire information comes out in terms of ATGC. And then there is a method to quantify that ATGC. And that ATGC expression levels, basically they are known as FPKM values, which is called fragment per kilogram per million. And number of expressed genes, how many genes are expressed for a particular kind of disease, time to complete a homework assignment, because time is also a measurement. So all this kind of data comes under what is called measurement data. And if you look at any kind of measurement data, it is basically of 2 types. Either it is called a discrete measurement data or it is called continuous measurement data. Now, what do you mean by discrete measurement data? Discrete measurement data means if certain isolated values are present in your data, then this is called discrete measurement. For example, number of members in a family. There may be 5 members, 7 members, 8 members, but I cannot say number of members in a family is 3.8. It doesn't make any sense. Or number of errors in the book, number of students present in the class. That means they are going to take some specified values, right? Or isolated values. Then this kind of data comes under what is called a discrete measurement data. And what is continuous measurement data? Continuous measurement data means some kind of, say, if I fix 2 and say height between 145 to 170 centimeter, then height can take any value in decimals also. 157.5, 157.57. You can add third, fourth decimal depending upon the accuracy of your instrument. So this is the basic difference between discrete and continuous measurement data. Okay, now this is something important. So far we discussed that there is a structured and unstructured data, but we are talking in this program about the structured data. And structured data is basically of 2 types. Either it is called categorical data or it's called measurement data. And there are different scales on which these 2 types of data are measured. If you look at the categorical data, there are 2 different scales. One is called the nominal scale. Another one is called the ordinal scale. Please remember, these 2 scales are for categorical data, nominal and ordinal. And there are 2 other scales for measurement data. What are these scales? Interval and ratio. Let me just repeat. For categorical data, 2 scales, nominal and ordinal. And for measurement data, interval and ratio, right? Now, I'll give you a few examples of nominal and ordinal. Why this is important? Because whenever we will work in SPSS and you enter some data, SPSS will ask you whether your data is nominal, ordinal, interval, or ratio. And if you don't have clarity about these scales, you will face difficulty in the analysis, particularly using SPSS. They are also useful in recognizing different kind of variables in other softwares like R even. Okay, now let's first of all go for the categorical data. There are 2 scales, nominal and ordinal. So what do you mean by nominal scale? A type of categorical data in which objects fall into unordered categories. That means you cannot order the categories. And look at the last line, there is no preference of one category over the other. That means every category is given equal weightage. For example, if I am looking at gender, male and female, I can write male as 1, female as 2. Or you can write female as 1, male as 2. Doesn't make any difference because everybody is human being. If you look at religion, I can write Hindu as 1, Muslim as 2, Sikh as 3, Christian as 4. Or you can write Muslim as 1, Sikh as 2, Hindu as 3, Christian as 4. Doesn't make any difference. So because everybody is human being, it's given an equal weightage. So bottom line is, if there is an equal weightage to each and every category, then we say that our data belongs to the nominal scale, right? These are examples of nominal scale. What is your gender? What is your hair color? Where do you live? So all these are examples of the nominal scale. And again, for the categorical data, there is another scale that is called the ordinal scale. As the name suggests, ordinal, that means there is some order. So here the difference between the nominal and ordinal is, in case of ordinal scale, you can arrange the categories in ascending or descending order of magnitude. So order becomes important. And one can arrange the categories either in ascending or descending order of magnitude, right? For example, socioeconomic class. Say lower class, middle class, upper class. So lower means the lower income group, upper means the higher income group. So you can arrange the categories in order. Similarly, education categories. Say primary school, then middle school, then high school, graduate, postgraduate. So all these categories can be arranged in order from the lowest to the highest. That is the only difference between nominal and ordinal, right? But the important point is the last line. The numerical distance between any two categories does not have any significance. For example, if I'm writing male as 1, female as 2, and subtract 2 minus 1, it doesn't have any meaning. Similarly, socioeconomic class, a lower class as 1, middle class as 2, upper class as 3, and subtract 3 minus 2 or 3 minus 1. It doesn't have any meaning. So please remember, whenever we are dealing with the categorical type of data, the numerical distance, etc., does not have any significance at all. All right. This is all about the categorical data. Let's look at examples of the ordinal data. These are examples of ordinal data. How do you feel today? I can understand this is the first day. You have just attended the inaugural session and this is the first lecture. So how do you feel today? I can very well imagine. Hopefully you must be in category 4 or 5, but at least it should be up to 3. But if you are below 3, I don't know. How satisfied are you with our services? At the end of the entire program, you will be given some feedback pro forma where there will be questions like very unsatisfied to very satisfied. That means very unsatisfied, satisfied lower side, very satisfied upper side. So idea here is you can arrange the categories in order from the lowest to the highest. And if you have a 5-point Likert scale, 7-point Likert scale, or a 10-point Likert scale, so you can very well imagine that is not on nominal scale. That is always on ordinal scale because you can arrange the categories in order. Okay, that's all about the categorical data. If hopefully these things will be clear to you, then let's move on to what is called measurement data. Measurement data also have two different scales. One is called the interval scale. Another one is called the ratio scale. Now, what do you mean by interval scale? In interval scale, mathematical operations may not be valid. There are many types of data where mathematical operations are not valid. Let me give you examples. Let's say some beauty contest is going on, right? And there are judges, say, giving score out of 10. Let's say first person gets a score of 8 out of 10, and second one gets a score of 4 out of 10. It's a beauty contest. So if I divide 8 by 4, answer will be 2. 8 divided by 4, answer will be 2. But I cannot make a statement that the person whose score is 8 is exactly twice the beautiful than the person whose score is 4. I cannot make such type of statements. Let's say one student has scored 90 marks in a test. Another student has scored 30 marks in a test. Divide 90 by 30, answer will be 3. But I cannot make a statement that the student whose score is 90 is exactly 3 times the intelligent than the student whose score is 30. Right? He may be intelligent in sports or in some other category. So you cannot make such type of statements. So these are the data where mathematical operations are not valid. Right? And moreover, in interval scale, 0 does not mean the absence of character. For example, if somebody has scored 0 in a test, it does not mean the person is not intelligent at all. Maybe on a particular day, his or her performance is not up to the mark. Next time he or she can score better. Let's say I say temperature 0. It doesn't mean the temperature is absent. It is still better than -5. So 0 does not mean the absence of character. So bottom line is, in case of interval scale, 0 has a meaning. That's why in interval scale, 0 is known as an arbitrary 0, not the true 0. So variables like beauty score, intelligence score, temperature, they're all measured through interval scale. So hopefully the idea about the interval scale is clear. Okay. And to overcome all such difficulties, there is a highest rating scale, and that is called the ratio scale. And ratio scale is also for measurement data. There are two scales for measurement data. One is interval, another is ratio. I have already explained where all mathematical operations are valid. And here 0 will be true 0. Let's say somebody is having all mathematical operations are valid. Let's say somebody is having weight 90 kg. Another person is having weight 45 kg. If I divide 90 by 45, answer will be 2. But I can always make a statement that the person whose weight is 90 kg is double the weight of the person whose weight is 45 kg. Nothing wrong with that. Most of the times we say that age of the father is 3 times the age of the son. Father is 45 years, son is 15 years. So it's 3 times, right? So you can divide, you can multiply, all these things are possible. But remember, in ratio scale, 0 means the true 0. That means basically if I say 0, it is non-existent. For example, if I say height 0, it is non-existent. If I say weight 0, it is non-existent. Age 0, it is non-existent. That's why 0 is called the true 0. So 0 has a meaning in interval scale, but in ratio scale, it is counted as a true 0, right? So this is also something important, summary of different kind of scales. Here I have put in all the 4 scales, nominal, ordinal, interval, and ratio. I think the idea about all the 4 scales is clear to you. And most of the time we are concerned with frequency or the counting. The counting is possible in all the 4 scales. In nominal, we can count how many males, how many females are there. In ordinal, how many people belong to the lower category, lower class, middle class, upper class, I can easily count. And interval and ratio, you can divide your data into small intervals, 10 to 20, 20 to 30, 30 to 40, go for counting. Counting is possible in all the 4 scales. But how do we compute median? We arrange the data in order and then we look at the middlemost value. Now, do you think it is possible to arrange the data in order from the lowest to the highest in nominal scale? No. So that's why median, etc. doesn't make any sense as far as nominal scale is concerned. But in ordinal, you can, in interval and ratio, you can always arrange from the lowest to the highest. Right? So that makes sense here. Then order of the values is known, whether this is lowest, this is highest. This is known only in ordinal, interval, and ratio. Can quantify the difference. As I mentioned already, that the difference, etc., does not make any sense in nominal as well as ordinal. Right? But it makes sense in interval and ratio. Can add or subtract only in interval and ratio. Can multiply or divide only in ratio. Have a true 0 only in ratio. So try to understand the summary of the different kind of measures. And this is something important. Sometimes we deal with a variable and it can be put into different scales. Same variable can be put into different scales. Let's look at education as a variable. Now, education can be measured from different point of view. Type of education, level of education, years of education. So if you are measuring education by the type of education, such as private or public, some people prefer private, some prefer public. So it is individual choice. So your data will go to the nominal scale. Whenever we talk about the education, it can go to the nominal scale. And the same variable education can go to the ordinal scale if you measured by the level of education, such as primary school, high school, college, graduate, postgraduate. So all these categories can be arranged in order. Variable is same education, but this time it will go to the ordinal scale because it's in terms of the level of education. Similarly, if you go to US or Europe, they will ask you about the number of years or years of education. 10 years of education, 15 years of education, 20 years of education, and the same variable can go to the interval scale. So please remember, whenever you come across some variable and you have to decide about the scale, look at the nature, how it has been measured, and how it has been measured will determine the scale. Very, very important. Same variable can go to different scale. Question is, how do you measure? Now, why I discuss all these scales in details? Because there are different statistical techniques. If you are dealing with the categorical data, statistical techniques are different. If you are dealing with the measurement data, statistical techniques are different. And problem comes whenever we have some mixture of the two. Some part is categorical, some part is measurable. For example, if somebody has designed a questionnaire, let's say relating to health, there are some questions which are categorical in nature. For example, education could be there, gender, right? Then marital status, occupation. So all these are categorical data. And there could be measurable kind of data like blood pressure, cholesterol, height, weight, BMI, etc. So they are measurable, and you want to correlate between categorical and the measurement data. Then the statistical techniques you have to use them very, very carefully. So in this entire program, we will come across all these type of data, categorical data, measurement data, and the mixture of the two. Okay. Now, whenever people deal with the categorical type of data, they generally compute percentages or proportions. They generally compute percentages or proportions. For example, what is the percentage of male versus the percentage of females? How many people belong to the lower class, middle class, upper class, and so on. And most of the time for categorical data, we draw bar diagram, pie charts. Please remember, bar diagram and pie charts. They are always meant for categorical data, not for measurement data. For measurement data, there are another graphs that is called histogram, box plot. They are for measurement data, right? Of course, if there is a measurement data, you convert this into categories, then you can draw bar diagram, you can draw pie charts. Otherwise, it is not possible. So pie charts, bar diagram are always for the categorical type of data, not for measurement data, right? And look at the last paragraph. Even if you are dealing with categorical data, many statistical techniques you can apply. Let's say I want to compute correlations. Then for categorical data, Carl Pearson, Spearman, etc., they are not possible. Then what are the correlations to be computed for categorical data? There is a gamma coefficient, there is a coefficient of uncertainty, there is a phi coefficient, there is a chi-square coefficient, there is a you can say tetra correlation, biserial correlation, point biserial correlation. So different type of correlations to be computed whenever people deal with the categorical type of data. And if time will permit, I will also discuss all these things today. In regression also, people apply simple regression, multiple regression, but they are all for measurement data. Let's say your some part is measurable, some part is categorical. Then there are techniques to deal with in regression also, like logistic regression, probit regression, Tobit regression. All these regression techniques are available, which can capture both categorical and measurement data. Similarly, different type of statistical modeling you can do. Analysis of variance technique is also for applicable for categorical data, but the names are different. For example, if there is a one-way ANOVA, then there is a substitute. If you are dealing with categorical data, that is called Kruskal-Wallis test. And if you are dealing with two-way ANOVA, then there is a Friedman test. So all these tests are there where you can handle your categorical data. And when people deal with the measurement kind of data, they have a lot of choices. You can compute mean, you can compute standard deviation, you can compute quartiles, percentile, deciles, everything is possible. Moreover, you can draw graphs like histogram, box plot. As I mentioned, they are always for the continuous type of data. And look at the last paragraph. In fact, one can perform all type of parametric and non-parametric procedures on measurement data, depending upon the assumptions. So tomorrow I will discuss about parametric and non-parametric part tomorrow morning. But now, please remember, if you're having some kind of data, if it satisfies certain set of assumptions like normality, independence, constant variance, etc., they are satisfied by your data, then we apply parametric test. And the most important assumption is of normality. And if they are not satisfied by your data, then we go for the non-parametric test, right? Okay. Now, before coming to the how to use SPSS, because if you are not familiar with the different kind of notations, different kind of representation of the data, then we cannot draw a valid conclusion out of the data. It's very difficult to draw the inferences. So if you don't know where to use mean, where to use median, where to use mod, and you are simply getting the answer that mod value is this, mean value is this, and you don't have any clue whether it is important or not, well, for your data. So it doesn't make any sense. So you have to be very, very clear where to use which one. So that's why we look at some of these statistics, which can easily describe your data. That is called descriptive statistics. Now, what do you mean by descriptive statistics? As the name suggests, that means you can describe your data into some manageable form, in the form of tables, graphs, or maybe in the form of some statistical notations like mean, median, mode, skewness. Let's say I give you a simple idea. Suppose I give you a basket in which there are 100 oranges. And my simple question is, I ask you to comment something on this. So somebody can comment on the colors, that there are different colors. Some are more yellow, some are of green color, some are of in between. And some of you may say that they are of different sizes also. Some are of big sizes, medium size, small size. So what you are trying to do basically, you are trying to describe the features of the data which is given to you. But it is just 100 oranges. Suppose I give you 5,000 observation. Suppose I give you 50,000 observation. Now, how you can describe that? That's why we need some kind of mathematical or statistics measure. And then we compute what is called mean, median, mode. They are helpful. They are known as measures of central tendency, and they are helpful to describe your data. Now, how do we compute mean? You add all the observation, divide by the number of observation. You will get mean. Now, I'll take up a very simple example. Let's say I give you a population values from 1981 to 1990. All population figures are available. And I ask you to compute mean. It's very simple. You add all the 10 observation, divide by 10. But let's say 88 population is missing. There is a question mark. 87 is available, 89 is available, 88 missing. And now I ask you to compute mean. You can compute mean of 9 observation. But 10th observation is missing. Cannot compute mean. So there are certain problems with mean, right? So that is, if there is a missing data, mean is not easy to compute. Remember, another problem with mean. Let's say most of the observation in your data, they lie between 100 and 120, between 100 and 120. So obviously, if you compute mean, it will be between 100 and 120. So somewhere maybe 110, 112, depending upon the number of observations in which part they are falling. But it will certainly lie between 100 to 120. If most 99% or maybe 100% of the observation are between this. But here is a question. Let's say one observation is 220. Now 99.9% of the observation, they are between 100 and 120. While one observation is 220. Now, if I include this observation into computation of mean, your mean may come out to be 160 because of only one value. While 99% of the observation, they are between 100 to 120. Do you think mean is the right representation? Not at all. Because of the one observation, it has shifted to 160. So mean is not a right representation. So mean doesn't make sense if there are certain outliers present in your data. Outlier means, outlier is an observation which is away from the main body of the data. That is called an outlier. For example, 220 is an outlier because 99% of the observation, they are between 100 to 120, right? So please remember, if there is a missing data, if there is an outlier present in your data, mean doesn't make any sense. That's why we look at median. Now, how do we compute median? Simple idea is we arrange the data in order and look at the middlemost value. Now let's look at the population data again. 1981 to 1990, 88 is missing. But no, population is most of the time increasing. In India, it will never decrease. So I can easily assume that 87 population will be higher than 86. 89 will be higher than 88. So you arrange the observations in order. 88, there is a question mark missing. And how you arrange the data in order. But what is the median? Median is the middlemost value. It will be around 85. So median makes sense, but mean doesn't make any sense, right? Mean is difficult to compute. Let's look at the second example also. Most of the observation between 100 and 120. One observation is 220. Now, if you arrange the data in order and compute the median, median will certainly lie between 100 to 120. Because only one observation is extreme, doesn't matter. Median will be the central. It will be the central value. That will definitely lie if you arrange the order, if you arrange them in order. So hopefully the difference between mean and median is clear, right? This is the formula for computing mean. And median, you know, you arrange the data in order, look at the middlemost value. Then what is mod? The most frequently occurring value. among the set of observations is known as mod. For example, look at very simple data. 1, 5, 4, 5, 5, 5, 7, 3, 5, 2. Right? So here you can easily see that 5 is occurring maximum number of times. So mod value will be 5 because as per definition, most frequently occurring value is 5. 5 is occurring how many times? 1, 2, 3, 4, 5. So 5 is occurring 5 times. So mod is 5. Let me change this data a little bit. Suppose here 5 is occurring 5 times and 7 is also occurring 5 times. Now there are two values, 5 and 7. 5 is occurring 5 times, 7 is occurring 5 times. My simple question is, what is the value of mod? Some of you may answer that 5 plus 7 divided by 2. Answer is 6. Absolutely wrong. Because 6 is nowhere in the picture. And the definition says the most frequently occurring value. 6 is not there in the values even. So it cannot be most frequently occurring value. So answer is wrong. So basically look at the definition, most frequently occurring value or values. So there are two most frequently occurring values, 5 and 7. So 5 will be mod, 7 will also be mod. So there are two mods in this distribution, in this data. If you are having two mods in your data, that is called bi-model distribution. If there are three mods, that is called tri-model, tetra-model. And for anything which is 3 and beyond, they are known as multi-model distributions, right? Okay, let me change this data a little bit again. Let's say every figure is occurring once. 5 is occurring once, 2 is occurring once, 3, 4. Every figure is occurring once. And my simple question is, what is the value of mod? Some of you may think of all the values are considered to be mod. But I think that is again a wrong answer. Why? Because look at the definition, most frequently occurring value. If every figure is occurring once, there is the most frequently occurring value. So what should be the answer? Mod will not exist. So mean exists, median exists, but mod may not even exist. Right? So try to understand the application of mod. Whenever mod is the most frequently occurring values, whenever we are going to a shoe shop and to buy shoes, there are numbers which are very frequently used. For gents, it is 7, 8, 9. These numbers are very common. There could be a number of 14. But how many people buy a shoe of size 14? Only few of them, like Kali or somebody, right? While most of the people, they get split into 7, 8, and 9. So this 7, 8, and 9, that is a mod value, a real application of mod. Hopefully, mean, median, mod are clear to you. Where to use which one, they are also clear. Now, once we know the mean, median, mod, why to look at dispersion? Why to look at dispersion? Dispersion means variability. Dispersion means variation. Let's say we look at very simple data set, 1, 5, 9, 13, 17. And here 7, 11, 9, 10, and 11. So if I add all the observations, sum will be 45. Here also sum will be 45. Here there are 5 observations, n is 5. Here there are 5 observations, n is 5. Now how do we compute mean? Compute mean when we add all the observation, divide by the number. So 45 divided by 5 is 9. Again here 45 divided by 5 is 9. Now mean in both the cases is 9. Let's say I'll not show you the data. I'll not show you the data. My question is, if mean of 5 observation is 9, can you make out whether this is series 1 or series 2? It could be series 1. It could be series 2. So that means, what does this mean? Mean is not describing your data completely. There is something missing. And that missing part is basically called variation or variability. And this is a very, very helpful measure of in statistics, because reliability of the instrument is being tested through this measure, right? Now, if you carefully look at series 1 data, its variation is 1 to 17. The lowest value is 1, highest is 17. And here the variation is very small, 7 to 11, very, very close. So obviously, if you see from your eye, the dispersion or the scatteredness will be less here, but it will be more. So you can say series 1 is more. Series 1 is having more variation as compared to series 2. But this is just 5 observation. I give you 50,000 observation. I give you 1 lakh observation. You cannot see from your eye. That's why we need to look at mathematical measures. And some of the simplest mathematical measure is to compute range. Range is nothing but difference between highest and lowest. So range in first case will be 17 minus 1, 16. That is called R. And the second case, 11 minus 7, that is 4. So where the range will be high, dispersion will be more. Where the range will be less, dispersion will be less. But range is not a very good measure of dispersion because it depends upon two values. That could be results of fluctuations of sampling area. Let's say I look at the example where most of the observation they are between 100 and 120. All observation are between 100 to 120. So if you compute range, it will be 120 minus 100. Answer will be 20. But suppose one observation is 220. Now you compute the range, 220 minus 100. So it comes back to 120. Range doesn't make sense then. What is the best measure of dispersion? Best measure of dispersion is basically called variance, or under root of variance is called standard deviation. Right? Now, how do we compute variance? I'll not give you any formula, but to tell you the logic behind this variance. Let's look at very simple logic. Here is the same data, series 1, same data, series 2. Mean is 5. Now in statistics, those who are not from statistics, the mean is denoted by X bar. For example, X bar is 9 in first series and 9 in second series. And any observation is denoted by Xi. This is the script we use for Xi to denote the observation. For example, put I is equal to 1. You will get in first series, your X1 will be 1. X2 will be 5. X3 will be 9 and so on. Similarly, in series 2, your X1 will be 7, X2 will be 8, X3 will be 9 and so on. Right? Now, let me do a very simple exercise. Suppose I take the deviations from mean, deviation of each observation from mean, and I start subtracting Xi minus X bar. X bar is fixed 9. Xi are these values. So your first observation in series 1 will be 1 minus 9, minus 8. Then 5 minus 9, minus 4. 9 minus 9, 0. 13 minus 9, 4. And 17 minus 9, 8. Same thing you can do it for series 2, Xi minus X bar. Minus 2, because 7 minus 9 will be minus 2. Then 8 minus 9, minus 1, 0, 1 and 2. Now, you able to convert, actually, you can see series 1, the 0 is there in the center. Series 2, 0 is in their center. And it's easier to compare in terms of 0. If your values are closer to 0, dispersion will be less because you have subtracted the mean. So, and if the values are far away from 0, dispersion will be more. So your picture will look like this. So if you look at series 2, your range is from minus 2 to 2. But what is the range of series 1? Minus 8 to plus 8. So if you look at this diagram, this is minus 8 to plus 8. That is series 1. And series 2 is only minus 2 to 2. So these observations are very, very close. So series 2 data is very close. So dispersion will be less. And series 1 data is more. So dispersion will be more. Very simple to look at. But some people in medical sciences, some people in social sciences, they are afraid of negative sign. Our data was positive, how it has come to negative. Then these statistics people are very smart. They say, okay, well, let's get rid of the negative sign. Now, how you can get rid of the negative sign? You scare all the observations, you will get rid of negative sign. Let me, in the next step, I scare Xi minus X bar square. 64, 8 minus 8 square will be 64, minus 4 square, 16, 0, 4 and this. And same thing you can do it here. So it will be 4, 1, 0, 1 and 4. But nothing has happened. You're able to convert just negative to positive. Now let's do one step ahead, because we are trying to find out some logic behind variance, some mathematical formula about variance. Let's take the sum. And sum symbol in statistics or mathematics is denoted by this sum. And there are 5 observations, so I can write I going from 1 to 5 and add the squares, add all these values. That means this plus this plus this plus this. If you add all the 5 values, you will get 160. And if you add all these 5 values, you will get 10. 4 plus 4, 8, then 9 and 10. So here it is 160, here it is 10. Now you are coming out with some mathematical formula. And one thing is clear, that where this sum is going to be large, variation will be large. And where this sum will be less, variation will be less. But Luckily, you have 5 observations in each. But let's say in series 1, you have 100 marks of 100 students. And in series 2, you have marks of only 20 students. I cannot compare them because there are 100 students. So this sum is likely to be more for 100 students. And this sum is likely to be less for 20 students. So I cannot compare in terms of sum. That's why we take average. Now, if you have 100 marks, there you need to divide by 100. If you have 20 marks, there you divide by 20. So your averages will almost be same. So let's take the average of this sum. So if I take the average of this sum, it is 160 divided by 5, 32. And here it is 10 divided by 5, it is 2. And you are coming out with some mathematical formula. 1 by n summation of xi minus x bar square. And this formula you have learned in your 10th standard, 11th standard, 12th standard. And that is nothing but the formula of variance. But logic is this actually. So people, we cram this, right? That this is the formula, statistics, very complicated. Actually, if you understand the logic, it's very simple, right? And this is the formula for variance. Here the power is 2. If I raise this power 3, in fact, if this power is 2, then we generally write this as M2. M2 stands for second order movements in statistics. If I raise this power 3, we call this as M3. That is called third order movement. And if I raise this power 4, that is called M4 and called fourth order movement. And these second, third, and fourth order movements, they are helpful to compute the next measure, which is called skewness and kurtosis. But moments idea should be clear. If power is 2, second order movement. Power is 3, third order movement. Power is 4, fourth order movement, right? So now you are coming out with the variance formula, and that is given in number of books, right? So that is called M2. Why M2, second order movement? Because it is power 2. If I raise this power, it will become third order movement. Now, question is, if I know the variance, what is the need of computing standard deviation? Again, there is a logic. Because suppose I give you data of 10 observations, right? And in 10 observations, let's say this is height data, height is measured in centimeter. So you will add all the 10 values, divide by the constant, which is 10. So your mean will also come out to be in centimeter. But look at the variance or units of variance. It is a square. So for the same data height, variance units will come out to be centimeter square. And if I ask you to compute mean plus minus variance, you cannot do that. Why? Because mean is in centimeter, variance is in centimeter square. These are different units. You cannot add, subtract, etc. That's why I compute standard deviation. If I take under root of centimeter square, it will come back to centimeter again. Under root and square will get cancelled. So units for mean, units for standard deviation will be same. Now you can add mean plus minus standard deviation, and that is required in many computation formulas, in computing confidence intervals, in computing in manufacturing process, how to control the quality of the manufactured products. We have 3 sigma limits, 2 sigma limits. So all these things are required because we cannot work with variance. That's why we compute standard deviation. Then there is another measure which is called coefficient of variation. Why this is required? Once we know the measure of dispersion, why this is required? Because mean, standard deviation, they depends upon the units. Now, let's say I give you 2 types of data. There is a height of the students and there is a weight of the students. And there are, let's say 50 students. You have a height and their corresponding weights. Now, somebody is asking me this question, whether weight is having more variation or height is having more variation. Now, even if you compute variance or standard deviation for height, that will be in centimeter. Or if you computing for weight, it will be in kg. So you cannot compare even after computing standard deviation because one will be centimeter, another is kg. But I want to see whether height is having more variation or weight data is having more variation. Then we compute what is called coefficient of variation. How we compute? Sigma divided by x bar into 100. Sigma stands for standard deviation. X bar stands for mean. Right? Now, if I'm just dealing with height data, so you have centimeter for mean. So units will get cancelled. And if I multiply 100, I'll get the percentage. Let's say height data. First of all, I compute the coefficient of variation for height. Suppose it is centimeter. Suppose this percentage is coming out to be 27%. Then I compute the same thing for weight, which is in kg. But now height is free from units. And kg will also be free from units. Sigma divided by x bar into 100. Suppose this is 17%. So I can easily say that height data variation is 27%, weight data variation is 17%. So height is having more variation as compared to weight. So you can compare in terms of coefficient of variation when they are measured in different units. That's why we need coefficient of variation. So all these things are important before looking into the interpretation of the data. And I'll not go into this slide. Quartiles, deciles, percentiles. Median divides the data into 2 equal parts. Quartiles divide the data into 4 equal parts. Deciles divide the data into 10 equal parts. Percentiles divide the data into 100 equal parts. Remember, please. Now, last thing before we switch over to SPSS, skewness and kurtosis. Now, why skewness and kurtosis are important? Because these measures help us to decide whether our data is having a normal distribution or not. Many times we compute skewness and kurtosis. It will describe some idea about the data, whether it is symmetrical data, whether there is a lack of symmetry. So basically skewness stands for lack of symmetry, and we have to measure the lack of symmetry. So basically everybody knows how to draw histogram. You divide your data into small intervals, count the frequency in each interval, and then construct the rectangles where height will be proportional to the frequency of that interval. Let's say if I look at the picture of the histogram, one bar is here, big bar, and there are 3 bars on the left hand side and 3 bars on the right hand side. And if I drop a curve will look like this, right? So if you drop a line from the center, so you can easily see that area on the left hand side is almost the same as area on the right hand side. If this is the case, that areas on the left and right, they are same, then we say that there is no skewness, your data is symmetrical. Your data is symmetrical. But suppose if you look at the shape of the histogram, let's say one bigger bar is here, and there are 3 bars on the left hand side and 10 bars on the right hand side. 10 bars on the right hand side. And if you draw a curve will look like this, right? And if curve will look like this, then you drop a line from the center, from the highest point. Area on the left hand side is less, but area on the right hand side becomes more. Then this is called positively skewed data. And other way around, if you drop a line from here, area on the right is less, but area on the left hand side becomes more, then this is called negatively skewed. Right? Question is, we need some mathematical measure. Again, just like mean, median, mode. So here there is a mathematical measure. So we compute the value of beta 1, which is based on moments. How do we compute? Here is the formula. So we compute m3 square raised to the power 3, m2 square raised to power 2, and then you divide m3 square divided by m2 cube, and you will get beta 1. And if the value of beta 1 is coming out to be 0, then you will say that your data is symmetrical. There is no skewness. But if value of beta 1 is coming out to be positive, then you will say positively skewed. And if beta 1 is coming out to be negative, then you will say negatively skewed, right? The question is, we know beta 1 and SPSS will compute for you, but odd power could be negative, it could be positive. For example, if I'm multiplying -1 3 times, you will get -1, so it's negative. Square can never be negative, but here you are squaring power 3. And if you are squaring any power 3, it will always come out to be positive. So under root, whatever is in the under root, that is always positive. Then question is, how do we look for negative beta 1 and beta 1? So it depends upon the sign of M3. Please listen to me carefully. If the sign of M3 is coming out to be negative in your case, assign negative sign with beta 1. Sign of M3 is coming out to be positive, assign positive sign with beta 1. So you can distinguish that whether beta 1 is greater than 0 or beta 1 is less than 0 or equal to 0. So that is called skewness. And the last part is called kurtosis. Now, how do we measure this kurtosis? Kurtosis basically measure the peakedness of the curve. Measure the peakedness of the curve. Okay. For example, let's look at all the three shapes. This is one shape here, another shape here, third one. Now, if I drop a line here from the center, area on the left hand side is same as area on the right hand side. But this is also true for this curve. Drop a line, areas are same on the left and right. Here also it is. I drop a line from the center, areas on the left and right will be same. But do you think shapes are same? Shapes are different. Here it is having high peak. Here it is having flatter peak. Here is in between. So to check the peakedness of the curve, how peak it is, how flatter it is, we compute another measure which is called kurtosis. How do we compute the formula for kurtosis? Again, based on moments, m4 divided by m2 square minus 3. I'm subtracting 3 so that comparison can be made in terms of 0 again. So beta 1 in terms of 0, beta 2 in terms of 0. So I compute this value and SPSS will give you if value of beta 2 is coming out to be 0. That means your curve is neither having a peak, not having a flatter curve. It's almost this curve, which is called mesokurtic in statistics, or mesokurtic means normal curve. But if value of beta 2 is coming out to be greater than 0, then it becomes what is called leptokurtic. Lepto means having high peak than the normal, having high peak than the normal. And if value of beta 2 is coming out to be less than 0, please remember this because I'll ask you questions there wherever we get the value beta 1, beta 2 in spaces. So beta 2 less than 0 stands for that it is platykurtic, flatter than the normal. So this is how we compute skewness and kurtosis. And roughly a rule of thumb is that if the value of skewness and kurtosis, and in value of beta 1 and beta 2, they lies between -2 to +2. Let me just repeat. If value of beta 1 and beta 2 lies roughly between -2 to +2, then your data is approximately normal. Approximately, not exactly, but approximately normal. But if it is below -2 or above +2, then you have to be very, very careful that it is why you are violating the assumption of normality. So that's why skewness and kurtosis make sense. Okay, and here is an exercise to you. There is a line A, there is a line B. And if you see from your eye, which line looks to be smaller, A or B? Yes, please. Faisa, which line looks to be smaller, A smaller or B smaller? I mean, if you see from your eye. So you can see A looks to be small, B looking larger. But let's check this. This is your A, this is your B. In fact, both the lines are same. But if you see this diagram, A was looking smaller and B was looking bigger. What is the reason? The reason is because this is closed from the both sides and this is open from the both sides. Human mind also works with the same logic. If you are sitting here listening to me with a closed mind just to get certificate, you won't be able to grab much of the things. But if you are listening to me with open mind, the same thing will look bigger to you and you can have a lot of knowledge after attending this workshop, right? Okay, so this is what I wanted to tell you, and life also works with the same logic. तो मैं हमेशा बोलता हूँ कि जिन लोगों को जो क्लोज दिमाग के हैं उनको जिंदगी बहुत छोटी दिखाई देती है और जो ओपन माइंड के हैं वही जिंदगी उनको बहुत बड़ी दिखाई देती है, right? Okay, and with this there are other statistical package which you will learn, so I'll skip this part. These are some of the references you can go through. There is if you want to master yourself on linear statistical models, you have book by Bowerman and O'Connell, Categorical Data Analysis by Elena Grasti. This is a very, very good book by Weiner W. Daniel on biostatistics. And if you want to master on multivariate techniques like factor analysis, cluster analysis, discriminant analysis, then there is a book by Naresh K. Malhotra. And if you want to master yourself on mixed models, meta-analysis, then counting statistics, then I have also written a book that is called On Medical Statistics by Suresh K. Sharma. So all these are important books which you can refer to. So with this, I'll end up the first part and I'll move on to SPSS. If you have any question up to this, you are most welcome to ask. Yes, please. Any question? I'll give you time to ask questions. Dr. Faz,
Yes, sir.
are you there? So if there is any question in the chat box or if you want to unmute anybody, they can ask the
Sir,
questions.
yes, sir. A few of them have asked about the PowerPoint presentation, sir. That will be up to you.
Okay, that will be that I'll send you. Don't worry.
Yeah.
Anything
And
else?
one of them is asking about the difference between parametric and non-parametric tests.
Because parametric and non-parametric test I have to cover tomorrow morning in detail. So you will come to know. I mean, simple idea is if your data satisfies certain set of assumptions, we have to apply parametric test, and tomorrow I'll show you. And if they are not satisfied by the data, then we have to apply non-parametric test. So that is tomorrow's topic. Anything else?
Okay, sir. Sir, one more is that what kind of data do we expect? Is it that the data is favorable for analysis if we get a symmetric skew and normal kurtosis?
No, this is not in your control. The data is data. It may be symmetrical, it may not be skewed, it may be skewed. That is not in your control. Only thing is you need to check whether your data is skew symmetric, whether it is symmetric, whether it is asymmetric data. So all these things you need to check after getting the data, right? And then we have to decide about the test. For example, if some patient is going to a doctor, then he explained that I am having such and such problem. Then and only then doctor describe the treatment that you have to take this and this. Same thing is in statistics. You come out with data, then statistics people, or you can check yourself that this is skewed data. If it is a skewed kind of data, we cannot apply parametric test. We have to go for non-parametric test. And if it is symmetrical, we can apply parametric test. So all these things depends upon your data.
So one more question is that on which ground we can categorize strata and how do we define strata?
Can you just repeat? I couldn't understand.
Yeah, on which ground we can categorize strata and how do we define
Strata or
strata?
data?
Sir, strata, sir.
Strata means
STRATA, strata.
strata means they are asking about some stratified sampling.
About, yeah. Yes, sir.
See, sampling I am not covering. I think that will be a bigger topic. We generally divide the data into different stratas, and with the assumption that within a particular strata, the population will be homogeneous. And if there is a variability, variability will be between the stratas. For example, if I want to study, say, health status of Haryana state or UP state, then all the districts in UP are not similar. There are some districts which are, let's say in Haryana, there is a one district which is called Panchkula, and there are health facilities. There are a lot of hospitals. And if you compare this with another district which is called Jeend, where the health facilities are not so good. So obviously in the entire, I can divide this and Haryana state into different stratas. And within a particular strata like Panchkula district, let's say I divide this into 20 districts. Then within a particular district, the health facilities will be same for almost all. And if there is a variability, variability will be between the districts. But within a district, you can assume that. So this is how we divide into stratas. Of course, this question is not related to my talk.
Yes, sir.
Yeah.
Thank you, sir. And one of them is asking about the books you have just mentioned.
Yeah.
That I
So
think
that
you
I'll
can
give
you
you
can
the
easily
PPT
find that.
Yes,
Yeah.
please.
No, that's fine. Continue, sir.
Yeah. Anything else?
Nothing else, sir.
Okay. Can you
So,
just give me 1 minute?
one more, sir.
Just
One more,
one
sir.
minute. No, I'm
Yes, sir.
not going anywhere because that person
All right.
has to come. Just a minute. So with all these basics, let's move on to now SPSS. How to enter the data in SPSS, how to label different kind of variables. Our break is at what time?
So 11:45, sir.
11:45. All right. And
11:45.
then we have class at 12, right?
Yes, sir.
Oh, very good.
The second session.
Second session. So now I'll come to basics of SPSS, and then we will move on to, in the second session, we will move on to the correlation and regression part. All right. So please try to be attentive because this is the most important part. How many participants are there right now? At present, they are
So
attending.
currently, sir, about 96.
96, so about 100. All right. So all the best because SPSS is a very, very important part of this program. And please remember, you are going to learn R also. You will learn some lingo and lingo or some other softwares too. But SPSS is such an important package. And here you will get the output. It's a menu driven, which is without effort, but you should know the interpretation. That is the most important part. So interpretation will be most important. Now I will start with, so let me minimize the screen. Hopefully you can see the screen, and I'll come up to how to enter data in SPSS. So this is the logo for SPSS. It is called IBM SPSS Statistics. Open. Yeah, it is just opening. We will come to the worksheet of SPSS. Now, SPSS is basically called IBM SPSS Statistics. It is no longer called a statistical package for social sciences. Whenever you are quoting, please write down statistical analysis has been done by using IBM SPSS Statistics, whichever version is, you can put into the bracket, version 20, 25, 26, whatever. So just press cancel here. You will be at the worksheet of SPSS. So this is called the worksheet of SPSS. It is just like the worksheet of Excel, right? Everybody knows about Excel. So what is the difference between Excel and this? If you compare this with Excel, there are rows which are also there in Excel. There are columns which are there in Excel, but they are written as A, B, C, D here. But here it is variable, variable, variable. That means you can start entering your variables here. Then in Excel, you have here sheet 1, sheet 2, sheet 3. But here it is data view and variable view. Otherwise, it is almost similar. So there are two ways to enter the data in SPSS. One is you can directly enter the data in SPSS. Another way is you can import the data from some other file, like Excel file, right? So I'll tell you from both angles. One is how to enter the data in SPSS. Let's say I start entering some data. Say marks of the students, 12, this. Just randomly I am entering few values, right? Not specifically, but just entering few values. Okay. So I entered few values here, like 12, 33, and so on. So 12 values I entered. Now you can see, notice one thing, that by default, it has chosen the variable name. You haven't given the variable name, but it has chosen itself. Variable 4 zeros and 1. Similarly, if I start entering the second variable, it will take this as variable 402, variable 403, and you can, let's say first, but this is score of the students, this is height, weight, blood pressure, cholesterol. You can enter so many variables, right? But question is, I want the exact name. Let's say this is score, so I should replace this by score. So that's why there is a variable view. You go to the variable view, you change this by score. Now you can see it is appearing. The actual name is appearing. Similarly, you can enter age, you can enter height, you can enter weight. But please remember, whenever we start with any numeric variable, whenever we start entering any numeric variable, SPSS automatically understand that this is a numeric variable. SPSS automatically understand that this is a numeric variable, right? But your variable may not be numeric. It could be date variable. It could be address. It could be name. Then they are not counted as a numeric variable. That is called in SPSS as a string variable. Let's say I enter a string variable. Suppose first is a male. Then it has taken. Then second is female. Now you can hear a beep. You can hear a beep here. Let me just enter and you can hear a beep. Hopefully you can hear a beep because it is not accepting female. It's not allergic to female. It's not accepting female. What is the reason? The reason is here. Because if you go to the variable view and look at the numeric variable, the width of the numeric variable was 8. But by default in SPSS, width of a string variable, which is not numeric, is only 4. So male is having 4 words, M-A-L-E. But female is having 6 words. So that's why it is not accepting. That's why it is not accepting. Dr. Faz? Dr. Faz,
Sir. Yes, sir.
are you there?
Yes, sir, I'm here.
Just a minute. So,
I'm here. What happened, sir?
yeah, I just need 2-3 minutes. I will be back because that person has come.
Okay.
Just hello.
Yes, sir.
Now I'm back now. Sorry for there was some emergency. Anyhow, so let's say we just want to enter that out. The score obtained by is also classified according to the gender. Some of them are male, some of them are female, FEMALE. And now it is not accepting, but you go to the variable view and you have an option to increase the width. Let's say I also make this 8. Now you can make this 8, come back to the data view and start entering your data. Let's say female. Now it will accept because you have increased the width, right? So you can see you enter 2 variables. One is score, another is the gender. Now, if you're dealing with 50,000 observations, it's difficult to write down male, female every time. It's very difficult. But as I mentioned in my first talk in research methodology, that you can write male as 1, female as 2. So let me choose some code so that it becomes easier to enter 1 and 2. Let's say 1 is for male, 2 is for female. There may be some 1, 2, 1, 2, something like this. I mean, some of them are male, some of them are female, right? But how SPSS will come to know that 1 is male and 2 is female? So you go to the variable view, right? And then straight away you look at this variable number 3. There are values here. And you start assigning the labels actually. So value labels, these are called. 1 is for male. Okay. Add. And what is 2? 2 is for female. 2 is for female. And press OK. And now you can see, come back to this. 1 has been replaced with male and 2 has been replaced with female. And it will be counted as a numeric variable now. Although it's a label, and your answer will be in terms of male and female. Whatever the table will appear, table will be in terms of male and female because you have given the proper labels. Otherwise, if you are not assigning the labels, your table will appear how many times 1 is appearing, how many times 2 is appearing. Then you will be in trouble. What was 1, what is 2? So always assign labels. This is called assigning labels, right? Now you don't require this variable. You do not require this variable. If you don't require any variable, you click at the top, not at this place, please. Not at this place. You click at this border, I mean, sky blue border, and then this entire column will get marked, and then right click, cut or delete from your computer. So this will be out of picture. And now this is gender, so I can replace this by gender. Similarly, let's say I want to enter one variable between score and gender, say age. Then variable is always inserted on the left-hand side where you place your cursor. Let me just repeat. Variable will always be inserted on the left-hand side where you place your cursor. Suppose I place my cursor here. Then variable which I want to insert will be inserted on the left-hand side. And there is a command, insert variable. And you can see a variable inserted on the left-hand side. Let's say I forget to give the score number, serial number. Then you can enter here and insert variable. So you can enter the serial number here. So this is how you can insert variable. So I just cut, this is just for your demonstration. So it's very simple to enter the data in SPSS with proper labeling. All right. Now, next question is, sometimes we need to divide our data into 2, 3, 4 parts. So how to divide our data? If you are carrying a pen or pencil, please write down. Let's say we divide this data into 3 parts. Those students who have scored less than or equal to 30 marks, let's say I give them this as code number 1. And those who are between 30 to 60, they are given code as 2. That means 30 marks to 60 marks. And those who are more than 60, I give them code as 3. All right, please note down, less than or equal to 30, code as 1, 30 to 60, code as 2, more than 60 marks, code as 3. Why? Because sometimes our aim is to pick up only those students who have more than 60 marks. Sometimes our score is to pick up those students who are having less than 30 marks, so that they are weaker student, we can focus on them. So our problems involve such type of thing. This is called categorization of data, how to categorize into different categories. So let me do a very simple exercise. So I'll categorize this score variable into 3 categories: less than or equal to 30, 1, 30 to 62, and greater than 63. Okay. Then how to do that? This is called transform. You go to transform, and then there is a what is called recode into same variable, recode into different variable. Always pick up the second option, which is recode into different variable, not recode into same variable. Otherwise, what will happen? You will lose track of your scores, and they will be replaced by 1, 2, or 3. Wherever observations are less than 30, they will be replaced by 1, 30 to 60 by 2. So you will lose track of your original data. So that's why I always recommend you get this recode into different variable. Let's do that. So now male, female are not visible. So there is an option here. If you place your cursor at this line, which is called pink line, you can move it anywhere. You can move it here, you can move it here, right? But if you place your cursor here, it won't move. So you can move from here at the border, right? So that you can see your data easily. Okay. Now, whenever we start doing any operation in SPSS, let me just repeat, whenever we start doing any operation in SPSS, two windows will always open. This is called the left-hand window, and this is called the right-hand window. Now, in left-hand window, all the variables which you have entered, they will appear. So we entered only 2 variables, score and gender, they are appearing. Let's say I enter age, height, weight, blood pressure, cholesterol, skin pore thickness, chest measurement, right? Then marital status, then education. All these I enter, they will all appear here. Education, occupation, they will appear, whatever the name you will give. Let's say there are 50 variables. Then in this box, you can see maybe 20 to 22 variables at the same time. Then this type of scroll button will automatically appear here below. Arrow will be down. And if you place this, if you click that arrow, you can see the next variable. Again, click, you can see the next variable. So you can see all the variables basically. Then important point, left hand window will show you all the variables, but you shift only those variables to the right hand window on which we want to perform analysis. So we want to perform analysis for score, not for gender. We want to make 3 categories of this. So I'll mark score and shift it here. Now it says question mark. What is your output variable name? Where do you want to store this? So give the name. Let's say I give this name as score, then underscore code. And don't forget to press this change. And if you want to give the labels, let's say I want more readability, you can give this as rather than underscore, you can give this a complete word. So what it will do, what SPSS will do, it will convert your score to another variable score code, which we need to define. And where it will appear? It will appear next to the vacant cell. So here the next column is vacant is here. So automatically one variable name will be score code that will appear here. Actually, now what I need to do? I simply want to replace the old values with the new ones. Old values are less than or equal to 30, new value will be 1. Old value 30-60, new value will be 2. Old value greater than 60, new value will be 3. So just click onto this. So there are various options here. One is if you are having up to some point, then lowest up to some point, then highest and above. And here is the range, just like 30 to 60, I have a range. So first I pick up this up to lowest. My cutoff is 30, up to 30. New value is 1. So add here, lowest through 30. Whatever the lowest up to 30 will be given code as 1. Next value is the range. Range is between 30 to 60. Give the new value as 2 and add here. Okay. Then next is highest and above. So I'll click onto this, say 60. And then new value will be 3. Add here. 60 through highest will be given code as 3. So now I have made 3 categories of this data. Now you must be wondering, some of you might be wondering, that 30 is appearing here also, and 30 is appearing here also. Where the 30 will go? It will be taken under code 1 or code 2. Let me tell you. There is no overlapping in SPSS. Please write down, there is no overlapping in SPSS. Right? What does this mean? Wherever you are specifying your cutoff for the first time, up to that point, every value will be taken care of. Let me just repeat. Wherever you are specifying your cutoff for the first time, every value up to that point will be taken care of. For example, we specified this 30 for the first time under code number 1. So up to 30 is taken care of by SPSS, including 30. But whenever we start the next one, 30 to 60, but 30 is taken care of. So it is basically not including 30. It is 30.0001 on 1 onwards, up to 60. So even if you start from 28, even if you start from 0 to 60, but up to 30 is taken care of, automatically SPSS will start from 30.00 onwards. So there is no overlapping in SPSS. And now once we have done all this, then you continue. And once you continue and press OK, and you can see that it has run the command. And now you can see that it has made 3 categories. And you can check categories. 12 less than or equal to 30. 33, 30 to 60. 44 between 30 to 60. 76 more than 60. Now you can give the labels. Same way you can assign the label just like you have assigned for male and female. So 1 label was less than or equal to 30. 2 between 30-60. And 3 he is greater than 60. Okay. So you have given the proper labels. Come back and press OK, and you can see the proper labeling. Now you can make tables. Your table will appear how many people are less than or equal to 30 years of age, how many are between 30 to 60, and how many greater than 60. Otherwise, it will appear in terms of 1, 2, and 3. And difficult to read what is 1, what is 2, what is 3. If you assign a proper label, interpretation will be easy to make, right? So then we come back to the data view, and there are certain things. For example, if you send me this file and save this file, how to save a file in SPSS? It's very simple. You go to file, you go to save as, and then let's say I want to save this as desktop. Choose your path, give the file name here and press save, and your file will be saved. Let's say I give the name as temp, T-E-M-P, temporary file. So it will be saved on the desktop. Name will appear here. That is called temp.save. The automatic extension of any SPSS file is SAV. For example, this is one of the SPSS file on the desktop. This is another. This is another. All these are SPSS files which are already there on my desktop. Right? So this is how you can save the file. Now, if you save the file, send it to me for analysis, then I don't know what is this score. Is it a score of physics? Is it a score of chemistry? Or is it a pain score of the patients? I don't have any idea. Then what to do? Here you can specify your labels that these are scores of the students. And when you save the file and send this to me, so I can read the label of each variable, that this is corresponding to scores of the students. This is corresponding to gender. Of course, it is self-explanatory. This is score code divided into 3 categories and so on. So if there is a age, you can write age is in centimeters, height is in meter or centimeter, age is in years, and so on. So you can write the complete detail, whatever you want, right? So that's why this label is there. And finally, this measure. For example, score, it is written that it is under interval scale, interval or ratio. Now, interval and ratio, that is for measurable quantities, measurable data. They are both covered under scale. Remember, interval and ratio, both are covered under scale. But nominal and ordinal, you need to specify. For example, gender. Now, gender is already nominal. But if this would have been scale, let's say it is written scale here, then you have to write down that this is nominal. Now we have made 3 categories. less than or equal to 30, 30 to 60, and they can be arranged in order from the lowest to the highest. Obviously, this cannot be nominal. It has to be ordinal. So I need to replace this by ordinal. What happens if you are not doing this? That's why I discussed scales in the beginning. If you are not doing this, you will face problem in analysis. You have to specify each and every variable, whether your scale is nominal, ordinal, which one, right? Okay, come to the variable view, data view again. So this is how you can label. And the next question comes. Sometimes our problem is to analyze only male data or only female data. Then there is an option. You don't need to make any separate file for male and separate file for female. There is no need. What you can do, you can go to data straight away, and there is an option which is called select cases. So if you select the cases, according to a particular variable, they will get selected. Let's say I click onto this. Now here all the cases are selected. If condition is satisfied, then they will be selected. If that condition is not satisfied, it won't be selected. Let's say I choose this. If condition is satisfied. So let's say I put a condition. So this is how you read. Select cases if, let's say, gender is equal to 2. 2 means female. Equal to, I need to put equal to 2. So it will pick up only those cases. Select cases if gender will be equal to 2. Hopefully you can understand. Press continue and press OK and come back to the data sheet. And what you can see, where there is a male, it has been struck off. It is struck off. Right? You can see in front of male, it is struck off. That means if I give any command, if you give any command, that only male data, sorry, female data will get analyzed. There is no contribution of male because it is struck off. There is no need to make separate file in SPSS. Similarly, if I want a male, then you change. Let's say data, select cases, and if make the gender is equal to 1. The 1 stands for male. And now you can see it's the other way around. Now females are struck off, it's only the male data. If you give any command, only male data can get analyzed. And I want to get my original data back. It's again simple. Go to data. And whenever, please remember, whenever we are splitting or making a filter, just like filter we are using, then one thing will appear on the right hand side, that filter is on. So you can see the filter is on. Your filter is on at present. How to make this filter off? That means to look into the entire data again. Go to data. Then go to select cases and select all the cases again. Select all the cases again. Then this filter will be removed. And you have back to the original data. Now you can see you are back to the original data. And there is no filter now. And you can remove this filter, click and cut. So it's a complete data. So this is how you can go for the selection of the data. Okay. Next is sometimes our problem is to transform the data. Let's say I want to make a log transform of this, or I want to make, let's say, inverse transformation or tangent, cos, etc. So that is also very easy. How to make a transformation? So there is an option here which is called transform. So you click on to transform. Then there is an option which is called compute variable. And it is saying that you can write down your expression. How to write down the expression? First of all, choose what we need to do. So what we need to do is to go for log transformation. Let's say log transformation. And log is an arithmetic transformation. So all functions are given here. All arithmetic. Then there are statistics functions also. For example, this is statistics. There is a string function and so on. So all these are there. Okay, let me go to arithmetic because log is the arithmetic function. Then all the arithmetic functions are appearing here. Absolute value, sine inverse, tangent inverse, cos, exponential, log to the base 10, gamma and this. So let's say I want to compute the log to the base 10. Then what it will do, the entire description will appear here. That it will compute log to the base 10 of the data. And shift it here. Then there is a question mark. That for which variable you want to compute log. Let's say we want to compute the log of the score. There is no idea of computing log of the categorical variable. These two are categorical. So I mark here and take this to this side. So log to the 10 of score. but OK is not appearing. Why? Because you have not specified the target variable. So you can specify the target variable. Let me make this as log underscore score. So it will give you log. Another variable will be generated where it will be placed next to the vacant. And name will be log score. That will give you a log to the 10 of all the score values. So you have completed your task. OK is here. Press OK. And now your result is there. You can see the log score. Log to the 10 of 12 is 1.08. Log to the base 10 of 33 is 1.52 and so on. So this is how you can make transformation. You can compute different kind of variables. You can compute differences. You can compute anything. For example, I want to compute difference between this and gender, although it doesn't make any sense. But if I want to do that, you can do that. Transform, go to compute, make this variable as difference, say DIFF, and then I'll remove this and difference between say log score minus is where is minus it is acting as a calculator gender, although it doesn't have any meaning, but just for demonstration, another variable will be generated and variable will be generated next to here log score. Difference name will be difference. That will give you difference between 1.08 and 1, 1.52 and 2. But that has no meaning. But just to give you that you can do any type of calculations here. So here you can see 1.08 minus 1.08 and so on. So I don't require this. So this is how you can make transformations, right? So I think the first part I have completed. It is not necessary you will always enter the numeric variable. You can enter any number of variables. For example, here type is string variable. I have already explained. Then there is a comma option. Let's say I want to enter salaries. So you can make use of this comma option. Say 47,559. That means 47,559 salary. Right? So generally we are in a habit of assigning comma. So you can fix that I want to assign comma after every 2 or 3, and then it will start assigning the comma. So do not press comma yourself, please. If I want to enter salary 49 and I press comma 449, then SPSS will not take this as a numeric variable because comma is not numeric. You have to use a proper format. So use the width 2, then left hand side, starting from left hand side, after every 2 it will assign comma. And in many countries people are not assigning comma, they are assigning dot, but dot has the same meaning as comma. Scientific notation, everything gets converted into scientific notation. For example, 1000 can be written as 10 into 10 into 10. That is 10 raised to power 3. And in SPSS, it is written as capital E03. Capital E03 means 10 raised to power 3. For example, if I change this score to scientific notation, so you will get scientific value. E in terms of E. Value is not changed. Actually, this you have to read 1.20 into E stands for 10, 10 raised to power 001. So what is that? 1.20 into 10. And that will give you 12. Basically, this value is 12. This value is 33. Value is not changing. Only thing is format is changing. So that is the meaning of this scientific. Generally, engineers, they require scientific notation. Then date, you can enter date according to the format. Choose your proper format. If you are in US, we have to write month first, then day and year. If you're in India, we have to write down day first, then month and year. So choose the proper format, and then according to that, you can do the calculations. Okay. So score, I think, coming back to the variable view and change this to numeric. I think by mistake, I made some mistake. Okay. All right. So this is the basic things which you need to understand in SPSS. So this is how to enter the data, how to split file, how to transform variables. Now we will move on to in 2 minutes, how to import, and then we will be having a break of 15 minutes and you can come out with questions. Now what I'll do, I will import the data from some other file. So I'm closing this file without saving this. No, I haven't saved the file. Let's say there is a file in Excel. There are many files of Excel here. Let me take some file. Okay, let me take this file. Show it to you. Suppose this is your file, mutation, age, locality, sex, religion, and there are 71 observations here, right? But not 71, sorry. How many observations are there? It says 71, but if you see, first line is your variable name. So basically there are 70 observations in Excel file. Remember, this is on desktop. Remember the path, please. And 2-3 things which you need to remember before importing the file into SPSS. Please note down. Number one, always write down the variable names in small letters. I have used small letters: mutation, age, locality, sex, religion. Always write down the variable names in small letters. Number one. Number two, do not use any special character in variable name. Do not use any special character in variable name. What are special characters? Ampersand sign, percentage, hash, dash. They are not allowed. Underscore is allowed. That's why if you remember, I use underscore, score underscore code. If you remember that. Log underscore score. I use underscore. Underscore is allowed. Number three, variable name should not start with a numeric value. That means I cannot write that this is age data and all the people are of age 40. So maybe I can write 40 age. That's absolutely wrong. Variable name will not be accepted by SPSS. Why? Because it starts with numeric. Of course, you can write age 40. That's okay. Age 40 is okay, but 40 age as a variable name is not okay. Right? Last thing, variable names should not contain any spaces. I cannot write the variable name as mutation of the gene or mutation of the gene number. I can specify. No, not at all. That is not allowed. Right? So it has to be a single word, and the width of the word should not be more than 8 to 10 characters. Not more than 8 to 10 characters. Now with this specification, this is the file on the desktop. I'll import this into SPSS. Just closing and importing this into SPSS. Let me open SPSS. Just wait for a moment. And we will import. This is a test one. File name is test one. Please don't forget to close the file. Otherwise, it will give you error that your file is open in some other application. Now, these are the steps to, and then I'll give you a break. File, open. Ours is a data file. So go to open data. Now it is asking where is your file. Our file is on desktop. You can, if it is on pen drive, you can go to pen drive. It is in some folder. You can go to that particular folder. Now it is not showing that test one file. Why? Because it is showing only those files and folders which are saved in SPSS. So all these are SPSS files or folders which are having SPSS files. But our file is Excel. So change the file type. That is Excel. Now you can see the test one is appearing. That is the file we want to import. Click onto here, the name will automatically appear here, and then simply press OK. Now please remember, if you are having an Excel file, there may be different sheets, sheet number 1, sheet number 2, sheet number 3. But SPSS will import only one sheet at a time. Only one sheet. So whichever sheet you want, that will get imported. But luckily we have only one sheet. So press open and one question it will ask. And here is the question. Question is, read variable names from the first row of the data. What was there in the variable name of the first row of the data? Your variable name, mutation, age, locality, etc. So that will be imported automatically. And if there are 15 sheets, it will show you a list of all the 15. We have only one sheet. So we will import this. You can scroll down to a particular sheet, then it will import that sheet. And press OK, and you can see the entire file is imported. This is mutation. This is age, locality, sex, religion, and we were having 70 observations. Let's see. All the 70, they are now into your SPSS file. And now you can do any kind of analysis. So after the break, we will carry out by doing some analysis. And in the meantime, if you have some questions, please, you can ask me if you have some questions. Right? I'll be back in 15 minutes.